Hello, my name is Bradley Barrett. I'm part of Group 5, the Superior Statics students, and this is Statics for Beginners. So what is statics? Statics is an applied science that is fundamental to certain branches of engineering, including civil, mechanical, and biomedical, and it's how we're able to look at and analyze forces in a fixed structure. So is statics really necessary? Well, with incorrect statics, you'll have bridges fall apart and things go wrong. And with correct statics, you can properly size structures in order to carry vehicles, pretty much make sure that things don't fall apart. So how do you solve a statics problem? Well, like any other engineering problem, you will apply the 5 steps of problem solving. This includes defining your problem, collecting information about the problem, generating a solution strategy, refining and implementing your solution strategy, and testing your solution. So let's define our problem. We have to determine the direction and magnitude of a force on this plate. And this appears to be some kind of support. And so what we might be doing is looking at these beams the forces acting on these screws right here, and making sure that they're strong enough so that they don't shear or it doesn't tear out of the material in the wall.
Hello viewer, just a quick interruption. So after some quick research, we found out that this particular problem is actually referring to something called a gusset plate. A gusset plate is essentially a plate in the structure that has 2 or more structure members attached to it via being bolted, riveted, or welded to it. It is used to connect beams or columns together. As you can see, they can look like this or like this. This is relevant as since gusset plates are such an essential part of a structure, it's crucial to make sure that's not going to fall apart and cost people their lives or jobs, depending on your priorities, not judging. So statics is a good way to double check that you're not going to lose a paycheck. Thanks to Bradley though for trying to explain this thing. We love to see it. Anyways, back to our regularly scheduled program.
And so that's sort of what we might use statics to find, is making sure that we can support whatever we need to support.
Hi, my name is Carla, and now we're going to move on with 2, collect information. This is where we're going to review all the information that the problem has given us, and then see how we can approach it. So first off, we know the magnitude of all the forces. This includes force 1, force 2, and force 3. The angle between force 1 and force 2, which is 30 degrees, and the vertical and horizontal proportions for F3, which as you can see is completely parallel to the ground. Now our unknowns is the horizontal components of F2 and F3 and the vertical components of F2 and F3. This is because they're angled, so we have to calculate these manually. So now that we've gathered all the information from the problem in the diagram provided to us, we can now move on to step 3 of the problem solving process, which is generating a solution strategy. So first off, what we're going to do is we're going to have a free body diagram in order to have a better visual representation of the forces in action, as well as to organize the information for reference whenever we use trigonometry. So in order to approach this problem, first we need to break the forces into respective horizontal and vertical components, or their x and y components. This way we'll be able to easily sum forces which are going the same direction, as well as find the magnitude which the problem asks of us. In order to find these forces, we're going to utilize trigonometry, which is the relationship between angles and the sides of a triangle. Specifically SOHCAHTOA, as they're the most relevant in this case. Secondly, we'll also be using Pythagorean theorem, a squared plus b squared equals c squared. That way we don't have to use trigonometry every single time we need to find a force.
We're now ready to implement our solution strategy into our problem. So we'll begin by taking the vertical components of each force. For our first force, we'll have no vertical component since it's going to be the sine of the angle times our force, and in this case our angle is 0 degrees, so our force vertical is 0 for our first force. For our second force, it's going to be sine of 30 times 800 newtons, which gives us 400 newtons. And then for force 3, since we know that there's a relationship of 3 over 5 for the sine theta, since opposite over hypotenuse is 3 over 5, and that our vertical here is negative because we're going downwards, we know that our force 3 is going to be equal to negative 3/5 times 700 newtons, which leaves us with negative 420 newtons. So, summing them all together, we get 400 minus 420 gives us negative 20 newtons for our vertical component. For our horizontal component, we are going to take a very similar approach to the vertical component, but with the cosine theta times our force to find our horizontal force. So for force 1, cosine 0 is equal to 1, and it's multiplied by 850, so we get 850 newtons. For force 2, we have cosine of 30 times 800 newtons, which gives us approximately 700 newtons. And then, just like the last one, but with adjacent over hypotenuse, since we have the cosine of the angle now, and we're going towards the right, so this will be a positive relationship, we'll know that the cosine theta is equal to 4/5, so our force 3 horizontal is equal to 4/5 times 700 newtons, which gives us 560 newtons. So, summing all the forces together, we get 850 newtons plus 692 newtons plus 560 newtons gives us a total of about 2100 newtons. And then to solve for the angle of our force, we just use our relationships with the cosine theta of our result times our resultant is equal to our horizontal total, and the sine theta times the resultant force is equal to the vertical total. With that relationship, we can put sine over cosine, canceling out the resultant forces. And since we have values for the sine theta of our resultant and the cosine theta of our resultant, we can substitute those values in and solve for the value of theta using inverse tangent, which leaves us with approximately negative 0.5 degrees. And then, using cosine theta times the resultant force, we can rearrange and solve for our resultant force by taking the horizontal total and dividing it by the cosine of our angle. So substituting those values in, we get 2100 over cosine of negative 0.545, which is approximately equal to 2100 newtons. So finally, our resultant force has a magnitude of 2100 newtons in the direction of negative 0.545 degrees, or 359.5 degrees.
And finally, after all that suffering, we can move on to the fifth and final step of the problem-solving process, verifying and testing our answer. So to begin verifying our answer that we got, we first have to go over the statics principles to defend it. Since all force is acted on the same point, the radius equals 0. Therefore, torque also equals 0. Secondly, the net force also equals 0 due to the fact that the beam has no acceleration as a result of the forces acting upon it. And according to Newton's second law, all force has an equal and opposite force acting upon it. Therefore, since our resultant force from our calculations has a magnitude of 2,100 newtons in the direction of 359 degrees, therefore the resistant force would also have a magnitude of 2,100 newtons, but in the direction of 179 degrees, to satisfy the equal and opposite force that would require the net force to be 0. So now comes the issue of, is this answer accurate? So in order to ensure accuracy, all the members of our group individually worked out the problem on their own time. Afterwards, we compared our answers in order to try to find a common one. Since we had no common answer, we reworked the problem together in order to find an answer that we agreed on and that would also satisfy the problem. And finally, is the answer logical? So obviously we have three forces. All of them were pointing towards the right. So from the get-go, that implies that there's going to be a very large x component. Secondly, one of the forces are parallel to the ground. Meanwhile, one points upwards and the other one points downwards, meaning that it's logical that those two are going to cancel each other out to some extent, and we would have a very low y component, and therefore it makes sense that a resultant force just has a very large x component and a very small y component if you look at the free body diagram.